Welcome everyone to the blast furnace. This is the first big turnout we've had back. So we actually came back here last month, but yeah, we didn't. It was a late decision in the piece to do it, so we sort of only advertised it a couple of days before. So you probably missed that one. We had a couple of people turn up, but yeah, this is the first, I guess, big event that we've had back. So I'll take you through the introduction. So for those that are here for the first time, basically how we work is we're going to go through a bit of coding or a bit of technology and how to use it. For the first hour, we'll have a break at about 7:30, thereabouts, and have a bit of a pizza break where we can meet and have a chat. And then after the pizza break, we'll actually hopefully get our hands dirty and try and use the technology that we've talked about in the code session at the beginning. They'll blur. We'll probably get our hands on a bit earlier than expected, especially with this one. It's not as full on as some of the others, and there's not a lot of setup, so hopefully we can get going a bit quicker. As always, firstly, thanks to CISP. So they sponsor us. They pay for the food and the drinks, and also Dashworks, Makespace give us the venue. So big thanks to those two guys. And also reminds me that if you need to go to the bathroom, directly behind you in the open door there. There's also a kitchen around the back if you need water or something. Drinks here as well, so feel free to grab a drink if you need a drink, cups and soft drink there. Alright, so tonight we're going to be having a look at the Telstra API for specifically sending text messages from IoT devices. So we're going to go through how to use your desktop basically to test the API and get it up and running, and then at the end I'm going to demonstrate how you can use the particle IoT boards to actually hit the API and have the device send messages in an alert system that I actually made for my NEN. So and I've got all the links there for GitHub, so if you want to check that out, both of those are going to be open source, and I'll be presenting it. So next month, trying to figure out which way we want to go. So after this, we're going to put it out to you guys and see what people want to see more. So we've got a couple of options. Node-RED's on the table, so that's basically graphical programming with JavaScript. But specifically you can run that again on low-level devices like Raspberry Pi, so we'd be looking at doing some programming with Node-RED on Raspberry Pi. Web dev, so how to quickly build and deploy a web app or a front-end app using Angular and StackBlitz, or mobile apps, quickly building and deploying mobile apps. So 3 topics we're sort of juggling around, and we're going to put it out and see what you guys want to do more. As always, if you want to support us, we've got the shirts here. You'll see some of us wearing them around. $10 each, and we basically feed the money back into the drinks and the food. And if you do take some photos, please tag the handles. Also, grab the Wi-Fi credentials while you're here, because we're going to need internet. I think the top one is a 5 gigahertz network, and the bottom one's a 2.4. Just in case you've got an old computer, you'll probably only see the top one. If you can detect the the bottom one, but if you can detect the top one, it's probably worth connecting to. It's going to be less congested. Yeah. Huh? Oh, yeah, of course. All right, so we'll push on. So firstly, this might make it easier for everyone. I have I've created a GitHub project, open source GitHub project with the steps, basically what we're going to work through tonight. So I'll do a couple things. For those of us on the Slack, I put it in the general channel. The other way I'll get it to everyone is right now. I'll just pump it out there. I'll send an email out through Meetup as well. I'll just put it on the. If you can go to the Meetup event, I'll put it as a comment on the event. But it'll just be handy to have because it's got all the links. It's got all the links for everything we're going to need to download. So just as a prerequisite, if you haven't already done so, we're going to be using Postman to test the API on our computer. And we're also going to need a Telstra dev account. So if you've got those set up already, great. Otherwise, follow the link on the GitHub repo. I've got it installed already, but I'll run the setup and just see if it goes through the paces. So Postman, bit of preface on that. Postman's basically a really cool way to not only test like APIs easily, but you can set up regular automated testing of your own APIs if you're building your own site or back end. But what's really good is specifically Telstra's actually built a Postman collection to test their APIs, which makes life really easy, which we'll see shortly. So once you run that, you should get something like this. It won't be as populated as mine, so mine's got all my API testing stuff in there, but it'll look, I guess, like a blank version of that. But once you're here, step one. Step two is we want to make sure we've all got a Telstra dev account. So you can go to Telstra dev. I'll register again with a different email just to see if we can all get the same bugs and errors together. Wonder if it's going to have a fit with the same mobile number. I accept. See what happens. What's your number? I'm gonna steal your phone number.
0472 654 715.
Ah. Alright, let's try that. And you should get an activation code.
009.
I've had, it's a bit flaky, the old Telstra dev site, and all the testing and playing with it I've been through. So just out of curiosity, has everyone got Postman installed successfully? Anyone had any trouble with that? Wait for my verification email to come through. So the only thing that really slows us down, I find, with a lot of these demos and setups is the security, the different various levels of two-factor. Okay. Nearly there. I nearly have my Telstra dev account. And I'm in. So if we're there, anyone struggling to set that up? No harm. I don't want to move too quickly. And then this is for later. We don't have to do this right now, but if you've already done it, great. But the particle account is for when we actually demonstrate how to work with the hardware. And the difficult part with making the particle work is not actually the device code, it's actually setting up the webhook on the particle cloud. So we can actually step through that without the hardware. But when it comes to then deploying code to your device, the calls you make to actually hit the APIs from the device are really simple. Also worth having this guy open. So we're going to be referencing the API docs for the Telstra. Ooh. Messaging API specifically. But I will show you, if you go in here and you have a poke around, they actually got a few different APIs. Track and monitor. You got a programmable network API, event detection, connected things API. Heap of cool little things to play with here. We're going to be focused tonight on the messaging API specifically, and to be honest, even a sub part of that. So there's quite a bit going on here. But if you're on your Telstra, if you're logged into your Telstra account now, you can actually just go into the develop APIs, and that's sort of how you get to this page, and then that'll take you to the docs for each respective grouping of API calls you want to make. So here we are. So step one, before we can do anything with the Telstra API, we're going to need to create an app. So once you're logged into your Telstra developer account, I might give us a bit more zoom. My apps and keys. So you can click on my apps and keys. And we're going to create an application. Call it whatever you like. I don't know how important these descriptions are. I think they're just for your reference. Once you start to create a few of these, perhaps. Basically, for every application you create, you'll generate a client ID and secret. And then as we get down the track, you'll see we use that to basically authorize the API calls. So you can have multiple apps with multiple client IDs and secrets to help track the analytics, I guess, of whatever you're doing with the API. So once you created it, you'll see here, you get this key and secret. So just take note of where to find that, because that's what we're going to need in a second once we get Postman out. What you get with the free tier here, let's see if I can, it wasn't, from memory it was too bad. I had trouble finding it a bit early tonight, but it wasn't. You get the messaging API, and I believe we get 1,000 SMSs a month for free, which is pretty good. One downside of the trial versus actually going pay-as-you-go or enterprise, which I imagine not a lot of us will probably do, mainly pay-as-you-go, is With the free tier, your maximum time limit for your access token, your device subscription, your API subscription is 30 days. So every 30 days you have to resubscribe your account. And it's just an API call, it's not a big deal. But if you actually do pay as you go, you then get the ability to set the expiry, and it's up to 5 years.
Now a question.
So yeah, we had in the Slack, we just got a question online. So once we get to the end, I'll show you how to do multi messaging, and yeah, the clickbait was that we can show you how to manage handling multiple Tinder dates. So,
Oh, I see.
but it's going to be practical, and I'm not on Tinder myself, but I'm told that it could be very useful. So we're basically set up here, we're ready to go. We've got our app, and if you need to ever go back and check that, create the app section here. So now we're going to set up Postman. So step one, I actually don't think I've got this. I developed the GitHub repo here on my other computer, so I better pull it. But if you want to pull the GitHub repo or just download it, so click on the code, drop down and just download the zip. Either way, basically what's going to save us time right now is I've got environment variables already set up for us, but they're really easy to set up as well. So I'll import them, but I'll show you how to set them up as well. Actually, yep, let's do that. That'll be for completeness. I'm gonna sync this repo in. God, not even signed in. Alright, so either download it, or if you want to do it manually, just hang out and I'll go through both. But effectively what we're going to do is a really cool thing about Postman, because when you're testing APIs, there's a lot of things you want to reuse. For example, your client ID and secret, or your access token. For every call, you're going to need either the client ID and secret or the access token. So Postman allows you to set them up as environment variables in the app, and you basically can address. So in your API call, you can just put double curly brackets with the variable name, and that stops you from needing to type it in every time. But it also goes two ways. So you can actually have the return from Postman update one of those variables, which is going to be really handy in a second when we start using the access token. So what we can do is we open up Postman. We're going to go up to the top corner here where the environments are. Click on the settings, and we're going to import. Choose a file, and if you downloaded my GitHub Telstra API collection folder, there's a Telstra API Postman environment.json. I already had it in here, so it's sort of imported too, but effectively you should have an environment that looks like this, but maybe with just one of the Telstra API variables. If you go inside that, it'll look something like this. So basically the environment variables we have here are the host, so that's the domain effectively where we're hitting the API. We have the client ID, which we're going to get from our app that we created a second ago, client secret, and the access token. Now we have to use an API call combined with the client ID and secret to get the access token, and once we've got the access token, that's what we then use to make the subsequent API calls. So I'm going to set mine up now, what you can do is if you jump back on to your apps, and here's your client ID. So copy your client ID in a Postman. Grab your client secret into Postman. Make sure you don't do what I do all the time and leave the carriage return in there. And then it should look something like this, but with your client ID and secret. So this is the starting point. Update those. Now I'm going to confuse myself here because I've got two. So I think that's the old one. So I'm just going to delete that. All right. So now we've set up our environment variables. Of course, and I've put the instructions in here in the GitHub repo. If you want to do that yourself, so you don't have to import the predefined ones I've made, you can just as easily go into environment variables, hit add, and just type out the variables that you saw there. If you're actually doing this and you want to know what variables to put in, like what are the environment variables I need for the Telstra API, I'll demonstrate that now. So create environment variables. Oh, I've skipped a step here, but that's okay. We can do this now. We're going to import the actual Telstra API collection into Postman. So one of two ways. You've got in Postman here, you can actually go import and file. You can actually just select the API, Telstra API JSON from my GitHub repo. So I already had it, but I've imported it as a copy there. I've got a few copies of it now. So that's one way. The other way is if you go to the GitHub link and follow this this little hyperlink here, it takes you to a basically a Postman reference, a reference on the Postman site to the Telstra API, and you can just hit open with Postman. And that'll add it as well. So once you've done one of those two, you should have the Telstra messaging API in a little folder like this. Just so I don't get confused here, I'm going to get rid of these copies. Is anyone fallen behind or need a second to catch up? So we've got the collection in here. So as I was saying, what this collection does is it has basically all the messaging API calls. If you're interested and you want to know how to get to that link without going to my GitHub, you go to the API docs for the specific API you want to play with, getting started, and then there's the run in Postman link there. So these are the calls. And the first one we have to do is actually generate an Auth token so we can make the API calls. If you click on it, you'll see right here it has an environment variable in here, the parentheses, the double parentheses, and it says host. So if you want to build the environment variables yourself, you know you need a host. And then if you click on body, you'll see you also need the client ID and secret. So you can actually build that environment variable data yourself by checking what the API calls need and just adding them to your environment variables. So that would be a case of going in here and it's actually importing the Telstra's actually added them for us. So they're all the environment variables you need for the Telstra API. So importing them from the file on my GitHub's actually added that in for us on the environments as well. So that's really nice. Got all my crap open here. So first we've got to do is select our environment. So I'm going to select my previously configured Telstra API environment. And what you'll see happen is now when you hover over these variables, it actually puts in your client secret, your client ID, and the host, which is tapi.telstra.com. If you want to verify these are correct, all you've got to do is actually go back to the docs, go down, let's have a look at just a quick example of authentication. And here, it actually tells you the full path just there. So for the Oauth Token API call, we're going to need that tapi.telstra.com/v2/Oauth Token. So let's have a look. If we go at the generate Auth Token, we've basically got that, right? We hover over here, it's got the tapi.telstra.com/v2/Oauth Token. And the client ID and secret are piped through to our environment variables. So the only place you'll run into trouble here is if you haven't selected the environment variable up here. If it still says no environment, then it won't. If you actually have no environment selected, these actually turn red and it just says unresolved variable. All right, so we're set up. The last thing to note that the Telstra Postman collection has nicely set up for us is a test at the end, and the test actually passes the JSON data, which has the access token, and then sets our environment variable to our newly generated access token. So once we get the access token, we don't even have to go into our environment variables and update it. This little test at the end here will do it for us. So all that's said and done, we can hit send, and we get an access token back. So some notes about this. Firstly, that should have updated our environment variables, and we can actually test that by jumping in, going into our settings, having a look, and you'll see now your access token is populated. To note about the access token, it expires every hour. So I'm going to show you how to create a subscription in a second for the app, which is Telstra API, which lasts 30 days, but the access token for making the calls expires every hour. So your flow, in the software that you write, actually has to handle being able to keep your access token up to date. And when we get to the particle stuff at the end, I'll actually show you how to do that. So all right, we've got an access token. Sweet, what's next? Well, Telstra says we have to create a subscription. And they do talk about it here in the provisioning section. So with a subscription, invoking the provisioning API to get a dedicated mobile number for an account application. So this is where it says, note, the free trial apps have a 30-day limit for their provision number. If the provisioning call is made several times within that 30-day period, it will return the expiry date in the Unix format. For paid apps, a provision number can be allotted for a maximum of 5 years. If it's made with active days greater than 1825, you'll get active days max response. So this needs to happen before, you basically have to provision your number, which is assigned to your dev account, before you can actually make the API calls. Luckily for us with Postman, it's basically all set up for us. If we go into the headers, literally all it takes is an access token. Because we know that's up to date, we should be able to go send. We got this nice little message back saying, destination address and expiry 30 days. So our app's now provisioned for 30 days and our access token will be valid for an hour. All that done, we're actually ready to try and send a text message with the API. So with the text message, with just the standard SMS API, the main thing you care about here is the body. So the body is the data that we're actually going to send in this post API request. Has a couple of fields: number, where you want to send it, the validity. I'll double check what they meant by what they're referencing in the validity there. So this in the API documentation, this is the send SMS is what we're doing. And the validity, how long the platform should attempt to deliver the message in minutes. All right, so it'll have a crack for up to 60 minutes by default. Notify URL. So this is important for if you send a message and someone replies to it. So the notify URL is basically the URL that Telstra will hit if they get a reply to that API call. To the text message, sorry, that you've sent through the API call. And of course, the message. So we can do hello world. And you fill out the number, which is your phone number with the country code at the front, and the message in the body that you want to send. The notify URL is optional, so you don't have to do it. I think if you just leave it there, it doesn't really affect the call just leaving it there. If you actually go back to the messaging, you'll see here I thought it might have said optional there. I'll leave it in for this first test, but I'm pretty sure we can get rid of it. So that's all done. Send. I've got your message has not been sent due to the suspected malicious use of the service.
They just kick you for spamming.
I'm just trying to see if I made any errors here. What I'll do is I'll do the standard, generate auth, just resubscribe. We've got everything else looks fine there. Oh, maybe, you know what? I'll just put a proper URL in here. Is anyone else getting that? Everyone's getting it? Sweet. Let's see what we've done. Let's see if I can have a look and see if there's anything particularly incorrect about what we've done. Anyone managed to successfully send a text message?
Yeah, but only if I don't have a URL.
Oh, so you actually remove that?
Yeah. So in the initial copy, you've got in the GitHub repo, you've got no URL in there, and that's done.
Sweet. There you go. So, all things being equal, you'll get a API message. So, step one, we can now use Postman to send SMSs. Yeah, so the stuff I got in GitHub is obviously configured correctly, and the stuff I'm doing on the fly is not, but that's okay. So get rid of the notify URL, solve the problem. So, again, if you want to keep track, if you want to follow this up later, I've lost my... In the README here, I basically got those exact steps we just went through. So setting up the Postman variables, getting your access token, subscribing, sending your message. Interesting fact about sending the messages, you can actually change this to an array. And if you actually put your phone number in there twice, you'll get 2 messages. I'll call it multi. So I've got my phone number in there twice in the array, send. should get 2 messages come through. So 3 in total there on the screen, but that is a way to use the SMS. So you can send multiple text messages with the same body, which is pretty useful. And it's how I use it for the alert system, which we'll demonstrate later on. But interestingly, on top of that, Telstra actually have a multi-message API call as well. Not too different. So basically, to use this, all we're going to do is change this main SMS call. We're just going to add the word /multi on the end. So we can go back to Postman, and what we're going to do is /multi. And then the object that you send is slightly different. So in the body, what we're actually going to do is change this to look something like this. So what this is it's an array of objects where each object is a body and a phone number. So you can send a heap of different personalized text messages. So I'm going to do this for myself. I'm going to send 2 to myself. Should be able to copy that. Again, watch out the sneaky little extra comma there. I'm going to get rid of the notify URL because I think that's going to cause problems again. So we'll have this object. If you want to, you can again copy the example. I had a sneaky little extra comma there, so watch out for that. Or you can get it from the Telstra docs as well. In the Telstra docs, you'll see over here in the payload section, you can just copy it there as well. Same. So what we've got here is the 2 messages. So I should be able to send that, and I'll get 2. One that says, hi mum, and the other one that says, hi dad. Now I've broken my oh sorry, that's MMS. Send multiple SMS is what we want. We should be able to put a comma there, and then I'm going to go again. If I was clever, I would have created an environment variable with my phone number in it, and I'd just be putting that everywhere. And so what we can do, I'll go, hi mum, hi dad, get rid of the notify URL, and I think the problem was that guy there. So let's have a crack at that and see what happens. Alright, so that one looks like it's went off. It's going to send me 2 messages. Hi mum, hi dad. I'm starting to get a few of these API messages piling up now. So we're sending personalized ones now. So what's cool about that? How can we up your dating game? Well, what we could actually do is go back into our environment variables. We can create one. Let's call it call it dating message. And we'll just write, are you free tonight? Let's change this to, I'll be a bit more generic. And then, what I call it, dating message. Fire that one off. And there we go. So now the first one to reply gets the date. Pretty straightforward. So next level would be to hook into the Tinder API and basically extract all your matches. I don't know if you get your phone numbers from them, I doubt it. Send your messages off and you're all automated. But yeah, the multi SMS, yeah, just gives you that element to personalize it a little bit. You can couple it with Postman in this instance to still keep the bulk of the message generic. I do have an example of this as well with the alert system. If you're writing this in code, if you're actually coding this up, it'd be much easier to obviously insert the default message, but just playing with it, you can definitely use Postman as well. Like I said, I could actually put my phone number and environment variable and that'd sort that out as well. So let me just check back where we got to. So we know how to use Postman to fully test this API. I encourage you to have a play around. There's SMS examples, MMS, getting the response for both. And if you want to test some of the other APIs, they've all got the Postman. They've all got the Postman files, so you can have a fiddle with them. We might break since the food's here, and then we'll go through the nanny alert system when we get back. So basically, we finished up with, we've got the ability to send bulk text messages, personalized, or we can use the same body for all of them. So what we're going to go through now is a way to basically configure this for an IoT device. So specifically, the IoT devices that I have set this up for is the particle stuff. So particle.io. So if you want to if you actually want to sort of follow along with this, you'll need a particle account. So jump on and set one up if you haven't got one. I've got a link at the top here on how to set up the particle account. Otherwise, yeah, just feel free to sort of see how it all works together. Particle, just for a brief introduction on that, if you haven't seen it, it's a really cool IoT platform. So they sell really cheap Arduino style boards that you can program with serial, like over USB, or you can program using their cloud IDE through Wi-Fi. And they also have a 4G version, and they used to have a mesh, but they've deprecated that now. So if you got someone trying to sell you particle mesh chips, they're probably trying to offload them because that's basically end of life. But just as a demo, just as a bit of background, let's have a look here. IoT hardware. I created using, I just want to see Electron. I used the particle Electron to create an alert system for my NAN. So a bit of background on it. You'll see here, so they've sort of got the newer ones here. So Cat M1, just 2G, 3G. If they still sell the Electron, was quite a some time ago that I did it. Yep, Electron 2G, 3G starter kit. So it's now called the boron. So if you're actually looking for this, they've sort of changed it to the boron, but these Electron kits, you can get these in Wi-Fi as well if your device is always going to be connected to Wi-Fi. But basically what I wanted to build is a device that was in some way connected to a lightweight key fob. And if my NEN pressed a button on it, it would alert whoever I wanted in the family that she needed assistance. So I've linked this in the at the bottom of the original the tutorial for tonight. But this should be open source. Everything I used to make it and how to run it, a video on how it works. Effectively, I used a particle electron, and it runs on the 3G, 4G network. So that was important for redundancy. So I didn't want the system to fall over because the Wi-Fi router died, or you know, the thunderstorm took out the power or something like that. So it was running off the 3G, 4G network. It's got a battery in it as a backup, but it stays on mains for as long as it can. And it's hooked up to a long range RF fob, and basically anywhere in her yard she can press the button on the fob and the electron gets the message. From there the electron does two things: sends an email and sends a text message to a bunch of people, my mother, my uncles, me, just family in general, and it's coded in a very specific way to allow her to mash it if she's in real trouble. She can just keep pumping out the text messages and the emails, and she can reset it. It also has the ability to detect if the mains shuts off. So it's always charging off mains, but then it's got a battery. So if the house actually loses power, it'll send a message saying we think the power's out, or at the very least, you know, she's kicked the wall socket or something, and then it's running off battery, and we know we've got a few hours of battery before the whole system will go offline. So heap of things built into it, but the main focus, or what we're doing tonight, is how does it send the text messages to the whole family. So firstly, sign up if you haven't already done so and create a particle account. Once you've done that, I think, let's see if we can get to it. I was going to see if we can get to it easily from the Particle website, but if you just Google Particle console, it'll either ask you to log in, or if you're already logged in, it should just take you to your Particle console. And so my particular console, I've got a couple devices there. I've got an Argon and a Xenon that are running as part of my home automation network, and then I've got my Electron that's running as my, what I call my nanny alarm. So step one, if you're buying one of these devices, setting it up, you go through you just follow the bouncing ball with their setup process, and you'll have your device appearing in your console like this. But what we care about right now is the integrations. So the way we actually interface with APIs with our Particle device is we use the console to set up webhooks. And so what we're going to do is set up, well, I'll show you my webhooks for my Telstra API, and then I'll show you the actual device code. So right now I've got one called SMS GT, and that's for get token. So you remember the first step, and like I said, we have to do it every hour, is we have to get an Auth token. So this is like this is one I prepared earlier. This is what the sort of the end result you get will look like. And the important part is the fact that it feeds the result back. So let's step through, let's see if we can just set it up. So you'll basically go into your particle console, into your integrations. What did I click? Add new integration, and we're going to be using a webhook. They've got a couple of others there, but webhook pretty much covers you for the rest of anything else, any other API you want to hit. You can name the event. Important thing to note about naming the event. So if you're using a 3.4G particle device, you pay for the data that goes across the 3.4G network. To call this event, you have to send some data across the 4G network. You want that data to be as small as possible because you're paying per kilobyte. So the shorter your name is, the less data that your particle device is going to have to use to call this particular webhook. So I'm going to call mine SMS test, but the smaller you can make it, the better. Now the URL is the URL that we want to hit. For this example, we'll do the send SMS one. So the only annoying thing here is we're using variables. So when we paste this in here, we actually have to change host to that host name. I think that's what it was, tapi@telstra.com. Just double check that here. tapi.telstra.com/v2. /v2. It is going to be a post type, and you can actually use your Postman call to translate these settings across. So what I'll do here is if I put these side by side, so it's a post type. We can see that says post up here. And if we go to the body, you can see raw is ticked, and this is actually a JSON object. So the format is going to be JSON. Another thing is you can restrict which devices can call these. So I could say I just want my nanny alarm to call this particular webhook. The list of devices will come up there. Click on advanced settings. Now this is where you want to put in, take note of these. These are interesting variables that you can put in. So say you actually want the text message to say what time the controller sent according to its own clock. These variables are good little hooks that you can do. So published at, if you actually put that particle published at, it'll put a nice time formatted string into your call. We're going to go custom, and then literally all you would have to do is copy the object that Postman has into there. Then the only other thing you have to check for is any of your headers and query parameters. So let's have a look here. We're going to need to put in these headers. So if we scroll down, it actually does two of them for us. Might just bring this across here, but be a bit clearer. So you can see the fact that it already identified that we're using JSON means it knew to put content type application JSON, accept application JSON. The only one we've got to add is the authorization. And so if you wanted to test this here, you could hard code the token in, but you can actually put the variable in, and I'll show you how to link that up shortly as well. And that's literally all it takes to create the SMS webhook. So at this point you'd go create webhook. So if I actually go back to my integrations to the one I prepared earlier, SMS test alert, let's have a look at how I did this one. So you can see here, what you actually want to put in bearer is particle event value. So this is what gets sent from the controller. It'll be called the particle event value, and I'll show you what that links to shortly. So if we go back to this this demo, and we actually just edit this guy. our bearer is going to be our particle event value. And so for any API call that needs that bearer token, that's basically how you would set it up. But the more useful one, or at least the one we're going to have to start with, is the get auth token. So what I'll do is I go back into the edit and I'll open the advanced settings, and let's compare this to the particle setup for the same API call, the Postman setup for the same API call. Generate auth token. So it's a post, but you'll see right here it's actually not JSON, it's actually a web form. And the reason we know that is if we click on the body, you can see raw is not selected this time, it's actually selected www or web form URL encoded. So we have to use the web form format for this particular API call, which is the this exact path here, if you obviously insert your variable. Now, with a web form, you actually get form fields. So you'll see with the JSON, you know, we've got raw and we've got JSON data, but the web form actually has these fields and values. So this is where you're going to put your client ID and secret. You have to set the grant type to client credentials and the scope to NSMS. So pretty much just copy that across from Postman. But once you got it working in Postman, it's pretty easy to set up the particle side of it. You'll also see that the only header we actually need is content type application URL form encoded. That is happened automatically, but you can verify that the header information here is just that content type. So that's all that's required of that. So once you've set up that webhook, you actually scroll down. The particle console will actually show you how to use it in your code. So if you want to call this function, this is actually all you do in your this example is in a loop. Basically, every 60 seconds, it's going to. This is how you would do a particle.publish, the name that we specified up here of the event, or the event name, which I said needs to be short, or ideally is short. The data that you're going to send, and you have to specify as private. The data, okay, whatever is in there, that's what gets passed to that particle event value. So that first SMS call we made, that is where we're going to put our access token. So effectively the workflow that we're working towards here is we have a webhook for the get auth token, and then a second call for the send SMS. We don't have to put the subscription call in our device here, because that's like you run it once and then you don't have to run it again till the thing expires. So with the trial account, yep, every 30 days, you're gonna have to remember to run that, or your API is gonna fall over. If you go pay as you go, which isn't expensive, if you enable that, you can put up to 5 years. So I dare say you never have to think about it. I say in 5 years time, you won't be using that device. It'll all be old hat. So you can also get data back, and this is why this is important, from these integrations. And it demonstrates right down here in this get integration response exactly how to retrieve the data. So rather than publish, you do a subscribe, and you subscribe to the hook response of your specific event with a function. So in this particular piece of code, it's going to subscribe every time that integration gets called. This hook, and it returns data. This hook will fire, and it will basically that whole JSON object that comes back from the API call will be fed into this char array, effectively, or this this pointer to this data here. So when we run the get auth token, if you look over at Postman here, this is what will get returned in this char array, effectively, as a string. So how do we use it? VS Code time. Conveniently was the last project I looked at. And I'll try and get the zooms up. Zoom in, Control plus. Right, let's have a look here. So let's have a look at the code. We don't need the terminal. Another fun fact about Particle, they have a VS Code integration. So you can use their online IDE, but for serious development, you can actually have it all set up from your VS Code on your desktop, and what that effectively allows you to do is push to your devices that are online. I don't know, I might actually say it here. So this one's configured for my Nanny alarm device, and so there's a bit of code here, but the API part of it is actually quite small. The majority of it is how I'm handling button presses, number of buttons, holding down to reset. I'm controlling an RGB, so if there's a buzzer inside, so once she triggers the alarm, it actually just rings. So the idea is if she accidentally bumps it, she'll know. I bumped it, and she can reset it. When she resets the device, it actually sends a message out to say false alarm, everything's okay, don't come running. Which is important because it happens. She bumps the button, so she has to have a way to basically communicate that she's accidentally bumped it, but it's not easy to do. So the idea is if she can't accidentally unbump it, with the goal being that if she tries to send for help and then as she falls, she hits another button again and resets it, no one comes. So she actually has to physically go to the device, hold it down for 5 seconds, and then it resets. But anyway, I digress. So in my code here, just in my setup, you'll see I've got a few things. I've got a couple of particle functions that can be called. And the main one is I've got my subscription to my SMS get token. So whenever that integration gets called and returns some JSON data, this will fire, and what this is going to do is run the pass token function. If we go down here, all the way down to where I've got the pass token function, it's a relatively straightforward bit of code here. All it does is it takes in this char array, passes it to a string, and then it sends this string into this little function I've written called try and extract a string. And this particular function takes in the whole string, the part of the string that you want to start with, and the part of the string that you want to end with, and effectively returns everything in between those 2 points in the string. Again, very simple. Gets the index of start, index of end, and then does a substring. I'm not going to go into detail on that, but the code's open source, so if you want to basically take it and have a play with it, you can jump on the GitHub, pull the code. But yeah, it's a little bit rudimentary, I guess. If Telstra's API call changes, like if they don't include token type anymore, this is going to fall over. So I could use Postman to make sure that response is always the same and set up a test on that. And if it does change, that test will fail, and I can come in and update my code accordingly. But you'll see here, so what I'm doing is I'm saying extract all the information between quotation, access token, quotation, colon, quotation, space quotation, no space, just quotation, and quotation space token type. If if you look at Postman for that response, so I'm starting with, you know, the quotation mark, access token, quotation, colon, space, quotation, and where is it? I've lost my Postman. So effectively, I'm stripping out that exact string, because then the thing that comes after it is quotation, comma, token type, which is that bit there. So I've got my quotation, comma, space, token type. So what's going to happen is whenever that get token integration fires, it's going to return that whole JSON object. I'm going to strip out just the token, and this little bit of code basically is a publish function that lets me console log on the particle console what the token was, so I can see what it does. So what I can do is, what I need to do is periodically get that token, update that token, make sure every hour that it's refreshed effectively. I have this loop. This is my main loop, just like any Arduino code. It's not that big. You can see starts here, finishes here. And all it does is when the system boots, it has this little if statement here that says, get the current hour using this simple call. If the last hour does not equal the current hour, and my particle has internet access, so using the particle connected call, then we're going to update the token. So it means one of two things. This is the first time the device has been turned on, because I initialized last hour to 25, maybe 25 makes sense. Yep. So I initialize it to 25 because at 24 would actually be fine, because what the time.hour function actually returns is a value between 0 and 23. So current hour, time.hour. So this loop will run. The last hour will be 25 on boot. The current hour will never be 25. So that should be, that statement should evaluate to true. And once it actually has internet connection, so I don't want to try and get my token until the device has got internet connection. Then once that all happens, I do this particle.publish SMS GT for the token. So by calling that, if we jump back over to the particle docs, you actually see here it just says, look, that's all you got to do, particle.publish SMS-GT. It is specifying a data payload if we wanted to send data, but because I don't actually need to send any information, I just need to call the webhook. In my code, I don't specify a data argument, and it's fine with that. So what happens is this call gets made. It will, all things being equal, return this JSON string. And when that returns that JSON string, this hook will fire, which then fires my pass token function, resulting in the token variable being set. So you can see token here. So token gets set to the access token. Now this is just a variable that I'm storing globally for the whole all functions and the main loop to access. So what have we accomplished here so far? Basically, every time the hour changes, and I have internet access, I'm gonna refresh my token, effectively refresh the token variable. The other little interesting thing here that I added in is if the last hour equals 12 and we have internet access and there hasn't been a daily test sent and the minutes equal 30, which roughly translates to every day, once a day at 12:30 when you have internet access, send a test message. So I've got a test alert function here. So this is, again, another webhook integration that we've created in Particle. So we go back to our integrations, SMS, test alert. I'll just go to edit because I find it a bit easier to read. So this is just, again, calling the Telstra SMS. And what it does is it uses just the single SMS API, but with an array of numbers. So it actually sends a message to myself and my mum, and it basically just sends this. This is a test message for the alert system. If you receive this message, the SMS functionality of the system is running. So at 12:30 every day, I can expect this text message. If I don't get it, it's going to tell me that something's happened to the system. API is not working, the system's down, something's wrong. That's the strict purpose of this is to test probably make sure the API is running more than anything, making sure something hasn't changed with the API. And it has to take the access token. So you see I've got bearer, particle event value, to actually send that. So it just pulls out whatever the data payload is. If you go back to this code and have a look, I actually set data to just the token string. So it's as simple as that. Particle.publish, the function, the token string, you have to put private, sent, and then we set daily test sent to true. What happens here is daily test gets sent to false at the change of the hour. So it gets, next time the time is 12:30, it'll fire it again. So what you can also do with Particle, and this is another great way to test, is you can create functions, Particle functions, and Particle functions can be called from the console. So I've got one here called test alert. So the function itself is called the function string is called test SMS, and it calls. So that's just the name, that's just the label for the function. So when I look for it in my Particle console, I'll know what it's called. And it calls a function in my code called test alert. So if you actually scroll down, here's this function here, test alert. So all Particle functions have a string as an argument. And in this particular one, I'm not actually using any arguments with it, but you still have to pass in an argument and return an int as part of what the Particle specify. But what happens is, when I fire the test alert function from my console, it actually calls one of my webhook integrations, SMS test alert. So the same alert message that fires at 12:30 every day, this is a manual way to fire it if I want to test it right then and there. Takes the token, it's exactly the same call as above. The only other thing it does is it does a Particle publish, and all Particle publish does here is prints in the console, on the Particle console, some information. So what do I mean by that? If we go back to our console and we go into my devices, my nanny alarm, you can see here the two functions, bat and test SMS. So actually correlate with bat and test SMS, these two functions here. And so all that's happening here is, if I call those with whatever strings I want to put into either bat or argument, on my Particle device, on the controller itself, it'll run this function or this function respectively with the string of data that I put into these fields. Neither of these strings take arguments. So for example, I can go bat, call that, and it's telling me low voltage. It's actually returned 0, which I think it means it didn't like it. Let's have a look at my battery status. If you're running out of battery, return 0. So maybe the battery is running low, maybe it's obviously running off power because we're talking to it, but yeah, so maybe I have to check the LiPo's gone or something. And if we go back here, the more useful one is, and so what's happened here is you can see that information that's logged there. That's simply the string. That's this particle.publish, and it's done B, and it's done a V, formatted the value that comes back from its fuel cell call, and then that's the state of charge as a percentage, and it sends that back here. So what we should be able to do is go test SMS 1. So this logs a couple of things. Firstly, it shows me that I've got a token. So it's got an SMS token, VM rah rah rah, and then it fires the SMS test alert function, and it's displayed the data. So that's the access token. That's that particle event value that's now been fed into the Telstra API call. And on my phone, I've actually received a message that says, this is a test message for Nanny's alert system, rah, rah, rah. So the particle console allows you to not only configure all this automation and ability to hit any API you want with the webhooks, but we can also put in functions directly on the console to allow us to test them, so we don't have to wait for events and things like that. So all this code here, yeah, like I said, if you want to pick and play with it, it's all on that open source GitHub repo. I've got a few things here. The test alert, I've got a false alarm. So like I said, it sends a text message if Nan resets the system, if she accidentally fires it. Or if she does have a fall and someone else gets there, they can basically alert that someone's arrived. So the message says something along the lines of, I think I called it FA, false alarm. Let's have a look. Nanny's alert system was triggered but was reset at, and you can see I've put the particle published at variable, which is just like a standard variable hook that you can jam in there. You don't have to do anything other than just put it in there. There's no configuration required on the controller side. And it says this means it's a false alarm or help has arrived. And you can see this gets sent to a whole bunch of numbers. And again, it takes in the access token that would have been sent as the data argument for that particular call. Yeah, we've got a couple of others in there. I don't have a text message configured for everything, like the power outage one will be in there somewhere, but I also, like I said, I also have these configured for email. So it's exactly the same sort of setup. These are all SMS. I just have these ones, which was the first ones I did was send for help. And for these ones, I actually use SendGrid and their API to send emails. Look, if you can do it with the Telstra API, you can do it with an email API as well. Exactly the same sort of setup. You just got to know what is it. It's a post type, JSON. You can test all this in Postman with the SendGrid API. And yeah, some custom data in there. So this one here, I've sent the content, Nanny's in trouble, needs assistance, with the particle published at variable plumbed in, and all the email addresses that I want to send that to. Subject, to, who's it from. This one here, I've been a bit lazy and I've hard coded an access token in that it's actually an access token that expires. So I'm saving myself a bit of dosh on the Telstra network there by not having to send the access token as kilobytes across the call. So that it's just an easier way to do it. But it is handy to know how to call the API and then get the result back to your controller, because you're going to hit that at some point, especially with the Telstra API. You need it straight out the gates. But yeah, look, that's really all I wanted to cover. Basically, I'm just trying to think as far as things I can leave with you guys.
I wonder if we can. I was hoping I'll be able to export these into some kind of JSON so you could use them as a reference later on, but hopefully this is all recorded, so if you actually want to try and configure this yourself and you're like, oh, how did he set up his webhooks, you actually come back through and watch these. You should be able to pause the screen on any of these and you actually just see the URLs, the data, but hopefully I've demonstrated that it's pretty easy to translate it from Postman to the webhooks, and once you've done that, it's very, very basic to call it from the controller code to call it is very straightforward. You know, they're single line functions, just reiterating the webhook is just a single line to subscribe, runs a function to actually call them again, single line. You can send a data payload as a string is the second argument.
Can you Slack me the repo real quick?
Yep.
People in chat want it.
It's actually on the Blast Furnace Slack.
Oh yeah, okay.
It's actually in the general there.
Okay, cool.
So yeah, it's very straightforward to work with. The controller code's pretty lightweight. Yeah, literally the only thing you got to watch is if you're trying to save the money that you're not sending too much data over your calls. However, with the Particle API, you get the SMS, you get the SIM card with it, and you get 4 or 5 megabytes a month. So you don't want to be smashing it, but for basic little things like this where they're not data intensive, it's not really a problem. Without sort of pandering on about this bit of code all day, there's not too much else. Please have a look at in the GitHub repo here I'll go back to the Telstra API one. You'll see right down at the bottom here, I've got, I'll post the link to this stream in the README with the timestamp for setting up the webhook. So if you come back to this, you're able to jump to this exact spot and just have a look at how we set up the webhooks in the particle integration section. And then I've got a link to the Nanny Alert project there if you want to pull the device code out and have a play yourself. Otherwise that's it. That's all there is for tonight. I hope you got something out of it, and I hope you can get all. I don't know, Sean, did you get yours working in or no good? Yeah, there's I did find when I was initially playing with this, the Telstra development site was a bit crappy. There'll be times where it would just not work as far as setting up the account. However, it hasn't failed me yet as far as the API being down or something when we've tried to send text messages. So the only thing I've got to debug now is I think I've got on the receiver on the alert system, I think the relay might be getting old or something because it chatted the other night, so I got flooded with a bunch of text messages and Nan didn't know what was going on, so everyone jumped out of bed and gave her a call, and she goes, oh, I don't know, I'm not pressing the button. And 3:30 a.m. I woke up and I got a whole bunch of alert messages coming through, but I don't mind the false positives. So it's all there. Hopefully there's enough resources there, and hopefully we've covered enough to sort of get everyone started with the Telstra API. That'll wrap us up.